Good morning, RSGA, STEM class, and whoever decided to watch this video. Today, we are going to explore how one engineer and entrepreneur, whose name was Elon Musk, used the principles of physical science to create revolutionary technologies that are changing transportation both on Earth and in space. While he isn't a traditional scientist making wonderful new discoveries, he is an engineer who applies physics in amazing new ways. Elon was born in 1971 in Pretoria, South Africa. Even as a child, he loved computers and science fiction. When he was just 12 years old, he taught himself programming and created a video game called Blastar that he later sold to a computer magazine for just $500. In 1989, he moved to Canada and later attended the University of Pennsylvania, where he earned 2 bachelor's degrees, one in physics and one in economics. He was accepted into Stanford University for graduate school in physics, but left after only 2 days because he saw huge potential in the internet and wanted to start his own companies. First, Musk co-founded an online payment company that later became PayPal. This company sold for $1 billion in 2002. That same year, he founded SpaceX, Space Exploration Technologies, with the goal of making space travel more affordable. Then, in 2003, he joined Tesla Motors, which aims to accelerate the world's transition to sustainable energy through electric vehicles. So let's talk about the importance of making rockets reusable. SpaceX and one of Musk's biggest innovations was reusable rockets. Think about this. Elon Musk compared single-use rockets to throwing away an airplane after every flight. If airlines had to buy a new plane for each trip, flying would be impossibly expensive. The Falcon 9 rocket is a 2-stage rocket standing about 70 meters tall and can launch satellites into orbit and even send cargo to the International Space Station, or ISS. Here's the revolutionary part. SpaceX became the first privately funded company to launch liquid fuel rockets that could land back on Earth and be reused. Before reusable rockets, a launch cost tens of millions of dollars. Now, SpaceX has reduced the cost to as low as $62 million per launch, or about $2,700 to $3,000 per kilogram to reach space. That is a huge reduction. So let's look at the physics of rocket landing. How does the rocket land itself? Well, that's really about physics. Let's break it down. Newton's third law tells us that for every action, there's an equal and opposite reaction. When a rocket's engine pushes hot gases downward with tremendous force, the rocket is pushed upward with equal force. For a Falcon 9 rocket to land, it must save enough fuel to slow down during the descent. The rocket separates from its upper stage at about Mach 6, that's 6 times the speed of sound. Then it uses its own engines to slow down, turn around, and land vertically. The rocket must carefully control its thrust, or its pushing force, and velocity, its overall speed, using computers that make thousands of calculations per second. Each Merlin engine is controlled by 3 voting computers that constantly check each other to ensure everything is working perfectly. Think about this as a complicated version of balancing one foot, except when you're standing on the foot is shooting on fire and you're traveling faster than a jet plane. Pretty difficult. So why do reusable rockets matter? Well, there are 3 main reasons why. Reason number 1, the cost. A Falcon 9 booster cost about $30 million to build, but only $250,000 to refurbish for the next flight. Over time, that saves billions of dollars. Then, number two, there's the environment. By reusing components, fewer new rockets need to be built, which reduces waste and material production and helps reduce space debris. You know, that flying junk in orbit that could damage satellites and spacecraft? Yeah, that's important. And then three, for future exploration. Making space traveler cheaper opens up the possibilities for more scientific missions, satellite launches, and even human missions to Mars. Let's take a moment to switch gears, literally, and let's look at Tesla. Founded in 2003, Tesla's mission is to accelerate the world's transition to sustainable energy. The company's first car was the Tesla Roadster, and that launched in 2008 and showed that electric vehicles could have an incredible performance and range. Unlike traditional cars with internal combustion engines that burn gasoline, Tesla vehicles are powered by electric motors and batteries. This means zero emissions while driving. That's the key. No exhaust coming out. Tesla's cars can travel up to 620 miles on a single charge, and some models can accelerate from 0 to 60 in under 3 seconds. That's faster than most hypercars. A Tesla battery isn't really different from the battery on your phone, your laptop, or smart device. It's just much, much bigger. Takes up the whole bottom frame of the car. That's huge. Tesla batteries use thousands of lithium-ion cells connected together. Here's how they work. Inside each battery cell, there's an anode, also called a negative electrode, and a cathode, also a positive electrode. This is separated by what they call an electrolyte. Not what you drink in your Gatorade, but it's an electrolyte that allows charged particles called ions to move between the anode and cathode. During charging, lithium ions flow from cathode to anode through the electrolyte, and this stores the energy. During driving, the ions flow back from the anode to the cathode, releasing that stored energy as electric power to power the motors. The battery pack is positioned low on the floor, which lowers the center of gravity and makes the car more stable and safer. That's an example of really smart engineering. So what's the deal with the motors that are used by Teslas? Well, Tesla vehicles use induction motors, which were actually invented over 100 years ago by a scientist named Nikola Tesla. That's who the company's named after. An induction motor has two main parts, the stator, or the stationary part. You see how they did that? Stationary. And the rotor, the part that spins or rotates. See how they did it? Rotor, rotates. The battery creates direct current, but the motor needs alternating current to operate. So it requires a device called an inverter to develop this type of electricity. When alternating current flows through the stator, it creates a rotating magnetic field. This magnetic field causes the rotor to spin, which eventually will spin the wheels and may even be connected through the axles, if it has any axles at all and is not direct. The speed of the rotation can be controlled by changing the frequency of the electricity going to the motor. There's a really neat, amazing feature on Teslas, and that's called regenerative braking. When you slow down, the motor acts like a generator, converting the car's motion back to electricity that recharges the battery. So instead of just wasting heat like brakes, Teslas actually capture that energy. Isn't that smart? Here's something amazing about electric vehicles in general. They're much more efficient than their gas-powered counterparts. Electric vehicles convert about 60 to 70% of electrical energy, from the battery to the power at the wheels. That's pretty efficient. Gas-powered cars only convert about 20% of the energy in gasoline and into movement, and the rest is lost as heat. This means electric vehicles can do more with less, which is better for the environment and helps with the overall costs. So how is Musk's impact really relevant today? Well, let's look at SpaceX. In 2012, SpaceX's Dragon spacecraft became the first privately owned spacecraft to dock with the International Space Station. SpaceX regularly launches satellites for communications, weather monitoring, and scientific research. And the company also launches astronauts to the International Space Station, or ISS, for NASA. Let's look at Tesla. Tesla has built a comprehensive supercharger network filled with fast charging stations where Tesla owners can recharge their vehicles. Millions of Tesla vehicles are on the road worldwide, reducing carbon emissions from driving. Tesla's technology has inspired other car companies to develop their own electric vehicles as well. Well, it's easy to say that the future might be kind of ambitious. Elon Musk definitely has ambitious goals for the future. He plans human exploration and settlement of Mars with a permanent base on the red planet, but he's going to do the moon first. SpaceX is developing even larger rocket system called Starship for this purpose. For Tesla, the future includes developing more affordable electric vehicles so more people can afford them, right? Make them cheaper, more people can drive. Improving battery technology for longer ranges and faster charging, and advancing autonomous driving technology. Whether all these goals can be achieved remains to be seen, but one thing is certain. Musk's companies have already changed how we think about space travel and earthly transportation. So here are the few of the takeaways that we can think of from what Elon Musk has done for us here on Earth and for the world of physics. Elon Musk companies has applied fundamental physical principles and physical science principles like Newton's laws of motion, electromagnetism, and energy conservation to solve real-world problems. He has innovated through engineering and helped make rockets reusable and electric cars more practical, and has kind of a creative way about thinking about problems that engineers can use to help make things better. He's had a real impact. The innovations are making space more accessible and transportation more sustainable. And then finally, he uses the scientific method. Success has come through testing, learning from failures, and continuously improving designs. Elon Musk's story shows us that understanding physical science opens up incredible possibilities. By applying physical concepts and that you're learning right now in school, such as forces, motion, energy, electricity, magnetism, engineers can create technologies that seemed impossible not too long ago. Who knows? Maybe we have the next brilliant engineer to help revolutionize transportation and space exploration right here listening to this video.